how viscous is that oil from my car? It's my understanding, y'all can tell me if I'm wrong, it's my understanding that when it gets put in, and at first, it's really nice and viscous. Woo! Got that engine going nice. Then you got me who's driving 1 hour each way, back and forth to work. 1 hour to get anywhere, pretty much. Okay? And you put that mileage on that car, by the time you go get that oil changed, it's this black goo. Okay? Everybody ever seen that? Okay? It's my understanding that's not quite as viscous. Is that right? Okay.
No, I think viscous is like the more syrupy it is, it's more viscous.
And the more viscous, we think about an engine. What does it help it do?
Well, like the engine is making the oil more viscous because, like, so I'm saying, like,
Oh,
okay. I think it's backwards. I think.
Okay.
So like a syrup would be viscous because it's sticking to things.
Okay.
Whereas like even the way it says water is less viscous. So like blood is gonna flow slower than water.
So then does that mean in my car, when they put the new oil in, is it more sticky?
It should be less sticky, but it's helping lubricate everything, so it flows better.
So, and does that mean it helps my engine run better?
Yes, because it should stick less, right? I don't know.
Okay. Well, now see, this is good because I'm like thinking, I don't know why.
It's described as more thick.
It's more thick.
Yeah.
Yes. And blood, the reason, and y'all tell me we're following the same line of thought here. All right, water flows quickly because it doesn't have all these parts in it.
Mm-hmm.
Blood does. We've got the formed elements. We've got like the red blood cells, white blood cells, platelets. We've got the proteins. We've got electrolytes. We've got the white blood cells. We've got all this stuff moving in it. Okay? But now here's the thing. Okay? Did that seem like we were on the same path?
I was just confused when you said you put it in, like talking about oil. I don't know.
Well, I think because I think of that oil as being thick.
Yeah, yeah.
Yeah, I think of the oil that I put in my car as being thick. So now, if we think about the blood, more viscous than water because it's got a bunch of stuff in it. Okay. Now here's the part we got to think about. The heart. Okay? The pump. We need the blood to move in, go to the lungs, come back, go back to the heart, and move out. Okay? Now, let's think about this in relationship to the water amount, which would help keep it fluid. If there's less water, the blood is now more thick or less thick?
More thick.
More thick. So if it's more thick, what do you think is going to happen to the pump, the heart, that's trying to move it?
It's gonna have to work harder.
It's got to work harder. So the better hydrated, okay, and that's the thing that I think is important, okay, because hydration, where do we get true hydration from?
Water.
Water. Thank you. Not tea, not soda, not coffee, not these power drinks and Monster and Red Bull and, oh, I probably shouldn't have said that. Okay, but y'all know what I'm saying, right? Water. So if we get the proper amount of water, that means it's not as thick. What does that help the heart do?
Work more productively.
Be more productive, less stress on the heart. This is the reason. Have y'all seen the stuff going around now about when you first wake up, how important it is to drink the 2 glasses of water?
No.
No?
I do that. I drink one of these every morning when I wake up, but why?
Because overnight, you've gone that huge amount of time without consuming, and then your body's using materials, hopefully working on cell repair, whatever the case might be, and you've gone a long time without fluid. And they say that it's more thick, and when you stand up, because of pressures and everything else that we'll learn about, it's the bigger reason for having a heart attack in the morning versus another time of the day. I know, right? Kind of cool. Okay, oh man. Osmolarity. The reason that we sort of need to understand osmolarity. All right, is everybody familiar with molarity? Like you can have a 1 molar solution. Like you could have whatever Avogadro's number is of salt in that solution, and that would be a 1 molar solution. Now, the difference with osmolarity, and yes, let this term bring to mind osmosis, which is the movement of water across that semi-permeable membrane, okay? This means the pressure of particles. Now let me explain what that means, okay? If we're in a blood vessel, okay, and if we're looking at the pressures of particles, okay, let's say that I have sodium chloride, which we kind of know as salt, okay, and I have created my 1 molar solution. Is everybody kind of following me based on chemistry? Okay, meaning that's the Avogadro's number that I have, okay? Now, when I put that into water, i.e. blood, because a whole lot of it is water, do these elements stay together or do they dissociate?
Dissociate.
They dissociate. They become Na plus Cl minus. Well, this 1 molar has now created 2 osmoles. Because I've got 1, 1. They dissociated. So let's say that this was, because we look at it in terms of sodium chloride, but we know that the salt that we consume could have sodium, it could have magnesium, it could have zinc. Does everybody see where I'm going with this? So based on that, I could have 3 osmoles. Does that make sense?
So that just depends on each person's blood. That's
Well,
very
just the availability.
yeah.
Yeah.
On like what you're eating and drinking and
Yep.
activities. Okay.
So even though it was only a 1 molar solution, it could generate the 2 osmoles. That affects the movement of water. Okay, because things want to go from the area of high to low. All right. Now, what if I had a glucose, which is C6H12O6? Does this dissociate in water? No. Glucose remains whole, so I would only have 1 osmole.
Is this something that we need? Is this just to give us like a
Unfortunately, when you get out into the field
mm-hmm.
and you begin to look at lab work will be reported to you in terms of milliosmoles. And yes, you're going to be taught how to decipher.
Yeah,
those
yeah,
type of results.
eventually like in the field, but is this something, do I need to write this down for the test? Is this gonna be on,
You definitely want to know what an osmole is.
I mean,
And-
specifically the green stuff that was showing.
Well, those are examples.
Yeah, that's what I mean, is it like.
So, like, if you want to write down 1 molar of sodium chloride, gives you 2 osmoles. That's a good thing to know.
I was saying, in the field, when they give you the lab work, they give you the patients, and they give you like the normal ranges too.
Yes.
Like if it's really bad, they'll call and
And be like, something's wrong, we gotta address
But
this.
most places, the doctor, you gotta fax the lab work to the doctor, and you gotta still call too.
Yeah. They make it real easy now
Yeah.
to read results. It used to not be quite so easy. But take a break, be back at 10:30.
Professor, I have a question
Mhm.
about